Hello everyone, and welcome back to my BPHO video series. In this video, we are tackling question 1H from the 2018 British Physics Olympiad. Let's dive in. First, let's read the question. A small particle of mass m can slide without friction around the inside of a cylindrical hull of radius r, which is built into a rectangle-shaped object of mass m. This rectangle object is supported between two rigid vertical walls by small wheels, allowing it to slide up and down without friction as shown in figure. The small particle starts at rest at the bottom of the hull and is then given an impulse so that it starts moving with speed v. What is the minimum speed v required to just lift the rectangle object m off the ground? Let's first understand what it means to just lift the rectangle object off the ground. As the small particle moves in a circular path inside the rectangle, it exerts a normal force on the surface of the cylinder. According to the Newton's third law, there will be an equal and opposite force, meaning the particle pushes against the rectangle and the rectangle pushes back. Now, to just lift the rectangle off the ground, this normal force from the particle must equal to the weight of the rectangle. And crucially, this condition must be met when the particle is at the topmost point of its circular path, where its upward push is maximized. Then, let's analyze the forces acting on the small particle at the top of the circle. The particle has two forces acting downwards, as shown in figure. First, its own weight, which is m times g. Second, the normal force from the rectangle, which at the instant of lift must equals capital M times g, the weight of the rectangle. So, the resultant force on the particle is mg plus capital Mg. This resultant force must act as the centripetal force required to keep the particle moving in a circular path at the top. The formula of the centripetal force is m times v squared over r, where v is the speed at the top. So we set the centripetal force equals to the total downward force, m plus capital Mg equals mv squared divided by r. So when for v, we get the speed at the top as the square root of m plus capital M times g times r divided by m. Now we will use the conservation of mechanical energy to find the speed the particle must have at the bottom of the circle. At the bottom, the particle has only kinetic energy. At the top, it has both kinetic and gravitational potential energy, since it has risen a vertical distance of 2r. So, using conservation of energy, 1/2 m times v bottom squared equals 1/2 m times v top squared plus mg times 2r. Substituting the expression we found for v top and simplifying the equation, we get v bottoms equals square root of gr times 5 plus capital M over m. And that's the minimum speed the particle must have at the bottom to just lift the rectangle off the ground. Thanks for watching. I'm Physics Michael, and I will see you in the next video.